Okay, let's unpack this. You've shared some really interesting stuff with us today. It's about a new tech launch, EON Digital Twin IQ.
Yeah.
Yeah, the announcement from EON Reality calls it the world's first spatial intelligence platform. Seems like they're big on AI, VR, AR, but focused on knowledge transfer. So for this deep dive, we need to figure out, okay, what is this thing? What problem is it solving? And why are they calling it a, breakthrough?
Right. And the source gets straight to the point on the problem. It's this huge inefficiency.
Uh,
They estimate $850 billion globally.
wow.
Yeah, specifically in how organizations handle training and sharing knowledge.
Mm.
The core issue, as they lay it out, is this constant tension. Companies always have to choose, right? Solve an urgent problem now.
Yeah.
Or take the time to capture how you solved it, make it reusable training material for later. Often you fix the thing, but the how gets lost.
I see. So you fix it, but don't learn from it organizationally.
Exactly. And that leads to all sorts of problems, the source lists.
Yeah.
Like wasted resources, people doing the same work twice. Someone fixes it, and later someone else tries to document it. Plus, there's expensive downtime. Taking machinery offline for traditional training, that costs money, and sometimes it's pretty risky from a safety perspective, too.
Makes sense.
Then there's just getting the right expert advice where it's needed. Specialists aren't always physically there, right? Geographic barriers are real. And the old way of doing hands-on training or building simulations, super expensive, hard to scale up. It's a gap, a big one, that EON claims they're bridging.
Okay, so EON Digital Twin IQ comes in as the answer. The source keeps calling it dual purpose. That seems important, doesn't it?
Yeah, definitely.
It captures the real-time guidance, the notes, while someone's actually doing the work, and it builds a digital twin of the whole scene at the same time.
Pretty much. That's the core idea.
And spatial intelligence, what's that about? The source says it's AI understanding the physical world, millimeter accuracy.
It's not just seeing objects, but getting the context, how things fit together in that space.
Right. And these AI avatars they talk about, like virtual experts.
Exactly. Specialized virtual guides you can drop into these photorealistic digital copies of the environment. The goal is making top-tier expertise available anywhere, anytime, sort of breaking down those location barriers we mentioned.
Okay, so how does it actually work? You mentioned a four-step process.
Yeah, this is where the tech gets really interesting and that dual-purpose thing clicks. Step one is environmental recognition and object ID. Basically, the platform looks around and understands what's there. It uses computer vision, spatial mapping, machine learning. They claim 99.7% accuracy for identifying objects.
99.7, that's high.
It is. It uses sensors you'd find on many devices, regular cameras, depth sensors, and importantly, LiDAR.
LiDAR. Okay, remind us quickly. That's the light-based radar thing for accurate 3D maps.
Precisely. Uses light pulses for really accurate distance measurement and mapping. So step one identifies the gear, the parts.
Yeah.
And crucially, the source says it gets the functional relationships.
How things connect and work?
Yeah, and even safety issues, like don't touch that, it's hot, or that needs to be grounded. Then step two is intelligent annotation capture. This uses natural language understanding, NLU. The system's not just recording, it's trying to understand what the user means.
Okay, NLU. So more than just words, it's getting the intent.
Exactly. It picks up on technical jargon, medical terms, factory floor language, whatever. It figures out why you're saying something, you're asking a question, pointing out an issue, confirming a step, and, get this, the source says it can even analyze emotional state.
Really?
Yeah, like, is the user stressed, confused, confident? So the AI avatar can adapt its help, maybe slow down if someone sounds hesitant.
Huh.
Step three happens at the same time as step two, real-time 3D scanning. While the user's talking, pointing, doing stuff, the platform is building a detailed 3D model of everything. Using photogrammetry, stitching photos together, and that LiDAR again, they're talking sub-millimeter precision.
Doing that while someone's working, moving around. That sounds technically tricky, doesn't it? Usually scanning is a separate static thing.
Oh, absolutely. And the source makes a big deal of that, this simultaneous capture during the actual task. That's part of their breakthrough claim. The digital twin isn't an extra job later, it just happened.
Got it. It's a byproduct.
Right. And finally, step four, real-time processing and digital twin generation. So it takes all that info, the recognized space, the user's actions, the scan, and instantly puts the right AI avatar in there. That avatar gives context-specific guidance step by step because it understands that specific situation. It can even trigger automated safety warnings if it sees a hazard. They call it a real-time knowledge portal. And here's a key bit. Every single time someone uses it, solves a problem, does a training, the platform learns. It gets better.
A self-improving loop.
Exactly.
Okay, this is where it gets really interesting for me. What's the actual impact? The source dives into the value, the ROI, and some numbers look pretty wild, like education, 90% cost reduction, 300% more student access to equipment. They mention a university lab, $50 million worth of gear.
Yeah, like NMRs, things like that.
And students get basically unlimited virtual access through this without tying up the real expensive machines.
That access point is huge, especially for expensive or sensitive equipment. It really opens things up.
Yeah. Then healthcare, 60% fewer training errors, 95% better procedural accuracy. That's huge. 0 patient risk for training, 247 availability.
The safety aspect there is massive.
For sure. Manufacturing, 0 production downtime needed for training. A 95% cut in accidents tied to training. They cite $10 million saved annually at one place just from productivity boosts.
Again, hitting those core cost and safety points.
And aviation. 85% cheaper training costs, unlimited practice for emergencies, engine failure, stuff you can't safely do for real with trainees, 0 training accidents. Doesn't matter if it's raining.
When you see numbers like that, you understand why they matter. They tie directly back to those big problems.
Yeah.
Safety, cost, efficiency, access, 95% accuracy improvement in surgery training, 0 accidents in aviation training. These aren't small tweaks.
It feels like a step change.
It suggests that, yeah. And the source backs this up. Claims documented ROI over 500% often with payback in just like 2 to 8 months.
Whoa, 2 to 8 months payback. That's incredibly fast for this kind of tech. How? Is it just that the problems they solve are that expensive?
That seems to be the argument, yeah. Traditional methods are just so costly. Think about downtime. Accidents, the costs there are enormous, not just financial, but human.
Yeah.
Cut those, reduce infrastructure needs, boost access. The savings apparently stack up really quick.
Right, it's tackling high-cost pain points directly.
Exactly. So if you listening are in these fields, healthcare, manufacturing, education, aviation, energy, defense, others they mention are, just interested in how tech can drive these kinds of big, measurable gains, these numbers are definitely eye-catching.
So, okay, beyond the results, what makes it stand out from competitors? The source uses strong language, insurmountable competitive barriers.
Yeah, strong words. They put it down mainly to that proprietary dual scanning tech, the real-time help plus simultaneous twin creation. They claim that specific combo is a first.
Okay, insurmountable. What makes that specific tech so hard to copy quickly? Is it just the tech itself?
It seems to be a mix. The complexity, for sure, integrating all those pieces, vision, LiDAR, NLU, real-time processing. Then there's their patent portfolio, 200-plus applications, apparently. That's a legal moat.
Yeah.
And critically, they stress the need for deep expertise across a lot of different fields. AI, spatial computing, cloud tech, and knowing the specific industry for the avatars. Getting all that talent together is tough.
Right, it's not just one thing.
No. Plus, they talk about first-mover advantage in this specific niche, and then network effects.
Ah, the more people use it, the better it gets.
Precisely. More users, more digital twins created means more data. That data trains the AI, making the avatar smarter, the recognition better. The platform's value grows with usage, which makes it harder for newcomers to catch up.
Okay. And the tech underneath.
They mention edge computing for those super fast response times you need in VR. A multi-cloud strategy, AWS, Azure, Google Cloud, for reliability and scale.
Multi-cloud. So they're not tied to one vendor.
More
flexible.
Exactly. Give them redundancy, lets them scale globally. It's also designed to work on common AR/VR gear and mobile devices, so you don't need special hardware, and really important for businesses. Security, they talk zero trust, lots of compliance certs like SOC2, ISO 27001, GDPR, HIPAA.
With enterprise-grade stuff, let's just quickly revisit a couple more of those use cases to make it really concrete. We mentioned the university lab, that $50 million in equipment value, giving students unlimited access to practice complex chemistry procedures. That's pretty compelling.
Yeah, opens up experiences usually limited by time or cost.
And the medical training one? Cardiac surgery. Residents doing 50-plus virtual procedures before touching a real patient, leading to an 80% jump in success rates and saving $15 million a year for one facility. That's incredible.
The safety impact alone is just...
Yeah. Removing risk from learning high-stakes skills.
Totally. And aviation again. Simulating the whole fleet, boosting training capacity by 300% because they're not waiting for physical planes, and getting a 95% first-time pass rate on check rides.
These examples really show the tangible difference it's making, not just spreadsheets, but competency safety.
Yeah, absolutely. Across really different, really critical areas.
So, yeah, pulling it all together. This dive shows EON Digital Twin IQ is really aimed squarely at that huge $850 billion knowledge transfer mess. It tries to merge solving problems now with automatically creating reusable knowledge assets, those digital twins. It's using AI, spatial computing, VR, all coming together to make expertise and hands-on training accessible pretty much anywhere.
A powerful combination. But here's a final thought, kind of hinted at in the source. The bigger picture idea of democratizing innovation.
How so?
Well, think about it. If you make top-level expertise and realistic simulations of super expensive or dangerous environments available globally, breaking down barriers like where you live, how much money you have, whether you can access rare equipment, could this kind of technology really change who gets the chance to learn advanced skills? Could it really level the playing field for talent and innovation everywhere?
It's a really interesting question to chew on. Taking the tech beyond just efficiency to actual global opportunity.
Yeah. Something for you, the listener, to consider.
Definitely. Well, thanks for sharing the source material. Fascinating stuff. This has been a great deep dive into how these spatial intelligence platforms might really be changing the game for training and knowledge sharing.